This is a tutorial covering how to procedurally generate your terrain. We're going to be using C# to manipulate the terrain data into generating whatever types of shapes that we want. Typically, a terrain is always flat, and then we're defining how high up it goes at various points. Not that we can curve over or anything like that. Now to do this, we're going to write a couple pieces of code. And so we have over here this terrain editor script. Let's go into the terrain editor script. And it's just basically a blank script that's here. The first thing we need is the terrain or the terrain data. We can access both, but I'll do this against the terrain directly. So public terrain. So now inside of here, after it recompiles, this ends up getting a reference to terrain. So I'm going to drag the terrain object into here so it gets this specific object. So now it's got the terrain here, and it can get to the terrain data from it. So to use that terrain data, we want to, let's put a stripe in here, or let's just put one point inside of this that does something. I'm going to say public void start. And now inside of here, I'm going to create a new vector, a new float, a new array of floats, two-dimensional array of floats, if I can get that in order. Var mesh equals new float 513, comma 513. Ooh. Now what's up with the 513? So terrain by default is going to be coming from, or is set at 513 for its resolution of the height map. So we're going to assume that we have that to start out with. Next, I'm just going to say that mesh, let's see, 0, comma, let's go with 10, comma 10 equals, so this is an array of floats. We're going to say it equals 1. Oh, whoa, I did parentheses. I meant brackets, square brackets. Okay, so we're setting one value, and then we're going to say this .terrain data set heights. And then inside of here, I'm going to pass in 0, 0, mesh. So what we're effectively doing is we're taking the terrain and we're saying, what heights are we going to use? Well, remember, we just created a new mesh, a new array of floats. So we have this wavy terrain that we want to get back to, that we end up wanting to get back to, and we just set everything to 0. So most of this is going to get set to 0, and it'll be flat at the bottom. Except for one spot. This one spot will be at 1. Now, we'll show you what 1 means. It does not mean 1 meter. And then we set the heights. Now you'll notice it's indexed, so we could actually change what positions we're applying. But effectively, right now, I'm changing out the entire heights of this. So as long as the terrain is set to default, this code will work. So now let's press play, because it operates from the start button. And there, it went up. But man, did that go up. In fact, that went up 600 meters. What 1 is 1 is the total possible height that it can reach. Your default resolution, your default size for the terrain is 1,000 by 1,000 by 600 up. Meters, in meters, the units inside of the world space. So this is 600 high. So ultimately, I probably want that to be much lower, like 0.01. I want it 1% of the height. Oh, and I need an F in there to say that that's a float. And let's run the same thing again. Play and stop. So now we have this one that goes up 6 meters instead in world space. And it's just one little spike, and that's it. Okay, so why don't we create something that manipulates several of these? So what I'm going to do is put this inside of a for statement. For And we're going to say I equals 0 to I equals 20. And we're going to say mesh equals this, Control C. I'm just going to paste that out into this one. And instead of it just equaling this, I'm going to say equals I. So it's no longer going to be at the 10 position. It's going to follow this stripe of I from 0 to 20. And it's going to be 0.01 times I. All right, so we've got that I field that's in there, and now let's go back over to here and let's play it. We should get a stripe where the corner starts at 0 and then gradually makes its way up to something about twice the distance out from this point. So let's hit play. And we did. Oh, the height's also much bigger now. So each one was, what was that, 1% per, not 1% at 10. So if I want it 1% at 10, I need to divide this by 10. So let's save that and run it again. And there, that's more the height that I was expecting. There we go. So now I've got that terrain in there. I've got this stripe that we're manipulating inside of our code. So effectively, you can change this anywhere. Additionally, we can also change it for just a particular region of the code. So I could get the original data. I could get the original data out by saying, let's comment this one out. Well, I'll just use this and I'll say mesh equals this.terrain data.get heights. So in this case, we're getting the heights. I'm going to call 0, 0, 513, 513. Okay, so I've got the data. This will get the data, and now we're going to extract what was already there. This will allow us to do things like, say, instead of this, I'm going to set a stripe. So let's actually set I. I'm going to use X as my axis, not Y. So by default, the first one in the array is typically your X, and then the second one is your Y. And I do have one quick message popping in. Let's see what it says. Yep. All right. And nothing important, so we will go on to this. We see the value of I. Okay, so on this one, we want the second one to be 0. So we're going to make this move along the x-axis, sort of. There's going to be a problem with that, though. Let's save this and return, and then we'll run it. And great, it ran, and it ran only along one of the axes, except for one problem. That's not the x-axis. That's the z-axis. So by default, we already assume that we're working with x and y, but it's flat against the ground. And in Unity world space, y goes up. But in terrain space, even though we swapped the x and z, we then swapped the z with the x. It's kind of confusing, but that's a key thing to recognize, that once you're down here, x is going to be along the z-axis, and y is going to be along the x-axis. So you just kind of have to think about the fact that that did that. You might need to play with it, let it do a small sample, put some stuff in some very obvious corners so that you can make sure you understand where it's working. And it's a good debug tool to have when you're first starting, that you put a block or something over in a corner where you're expecting to line it up with something else. That way you can identify and recognize which axis you're actually on. Because that part throws me off almost every time that I start it. Okay, so now we've manipulated that. Now I want to go for that rolling hills look. So in this case, I want to traverse through every single object that's in here. Oh yeah, and another key thing is, since I grabbed the data on this, that meant that it retained all its original data and only edited the parts that I added. So it edited these positions, which does happen to have one matching piece, which would have been 0 as well on both sets. So it didn't really matter. But I'm going to write another piece of code here. Oops, Control KC. No, here, select those, Control KC. code comment. All right, and instead we're going to do for, and I'm going to change the variable to x, and we're going to change that to, I don't want to have to keep typing in this 513. I shouldn't be doing that. So I'm going to say var res for resolution equals this dot terrain data dot height map resolution. That is our height map resolution. And it's also one integer. This is an important factor to understand, that when you are setting the resolution of a height map, it is a square. It is going to be a square. You cannot make one side longer than the other. The default operation of this is that the height map has the same width as height. Okay, so now that I've got that, I can start changing things out. So res will change out 513 here, 513 here, 513 here, and 513 here. And the length down there. Now I'm going to do the exact same thing for, and actually I'll just do this. Copy those, C, and then paste. And change these values to Y. All right, so now I'm going through every single XY position inside of this array, and now I need to set it to a position. Now I'm going to use something called Purlin Noise. Purlin Noise is used to put in a small variation inside of any type of surface, and it was designed to make surfaces look more real in the perfect looking, not realistic at all, original 3D graphics that we would see. Okay, so to start creating those mild distortions, it couldn't just be like jagged cuts and cracks. There was a smooth transition. And so we can take advantage of that same thing, and there's lots of ways that you can use Purlin Noise outside of terrain, or setting hills in terrain. Okay, so inside of here, I'm going to say mesh x comma y. And I suppose one thing that you could do is when you're manipulating this, you could just swap the x and y when you're setting these values and treat everything else as you would expect the x and y to work. The big point is at one place you have to switch the x and y value. Okay, so mesh x, y equals, and now we're going to say mathf.Purlin Noise, because Unity has provided its own implementation of this, which is great. And we're going to say, well, before I do, let's get a multiplier in here. Public float multiplier equals 0.1f. So we'll start at 0.1. So it wants an x position and a y position, and it's going to give us a value back between 0 and 1. And remember that our terrain height is also ranged between 0 and 1. So and I don't want my terrain height to peak off at the top. So whatever it's going to come up with, I want to multiply that by multiplier. Next, I want to pass in the x and y location. But I want to make sure that we're even going to be able to see the distortions that are happening on this. So that kind of matters. And we're going to have to reduce our x and y positions over this map to see it on a larger scale. So I'm going to say x times multiplier, comma, y times multiplier. Let's save it. And so basically I'm multiplying all of these by it, which means our x position is actually going to be a decimal of our x position, and our y position will be the same, and then the total value we get out of this, instead of being between 0 and 1, will be between 0 and 0.1, the multiplier that's up here. And we can change that later to see effects that it has. So now when I run this, these lines are going to disappear because I'm resetting them. It didn't matter that I actually grabbed the original data. I could have just used, I don't even need to use this line now. I can just create a brand new mesh for it because I'm rewriting everything. So none of the original data is retained. Why even bother getting it? Okay, so now that we've got the code, let's play. And now I'm going to stop and exit out of this. And this created this Purlin Noise effect. It's a little easier when you look at it from the top. You start seeing all these shadow effects and everything. And You can see that there's definitely kind of a pattern going here, but it's not really one you can track very easily because the Purlin noise is kind of all over the place. There's no specific pattern that seems to repeat from one spot to the next. They all rise up at different levels. But you do end up seeing this octave system. That's generally what they call it, where they take a very sharp point and then they put some finer gradation between it and the next points. So you see this, you see where it slopes down and off to the sides and does kind of a smooth transition from one to the next. So when we zoom out, we end up getting a texture that looks something more like this. Anyway, so that's our Perlin noise inside of the system. We just created an engine right off of the top of our heads from doing this that gives us this kind of distortion in the fields. Now we could also manipulate this to a much smaller number. So let's go to terrain and let's change it to 0.01 and play it again and stop this. It looks all flat at the moment, which it probably effectively is flat. There is a very small amount of changes happening here. So let's actually change that to 0.05. Or try 0.03 is probably better in this case. You can see the tiny variations, but it's basically one of those hills passed across the entire slope down to only 3% of the height. So let's play this now to get the new effect in. And there we go. This kind of looks like sand dunes now. And that's how we can create this Purlin noise system to just manipulate the code inside of this. Very, very little code. This is effectively all the code it takes to generate that. So there's a lot you can do. You just have to come up with what type of functions and systems that you're going to apply to generate those pieces of terrain. And it works better the more systems you cross-combine. So one of the next sections I would recommend looking at with this is getting in the splat map, so you can start editing those, and that'll be in a different video. Additionally, you can also look at when you apply objects to it, like trees or buildings or structures, whatever you're going to put in there, that you also change things about the terrain height and the level of the and what type of splat maps are affecting it to get a much better, more higher quality terrain at the end.